Alright, having understood the notions between weaker predicates versus stronger predicates, which can either be used as a precondition or as a postcondition. Now we would like to add one more aspect into the discussion, which is inheritance. Let's recall what we said previously in the review lecture for inheritance. So the fact that we can allow polymorphism, for example, you can see we declare the variables of different static types, and then we simply try to do variable substitutions. And for every assignment over here, we are basically substituting my phone, which is of static type of smartphone, by something that's maybe statically different. For example, we are substituting my phone of type smartphone by iPhone of type iPhone 11 Pro. And we said that such substitution would be valid because my phone over here would be descendant class of smartphone. That's something we review in detail from the previous lecture. Okay, so we can substitute variable for each other as long as you satisfy the rules for the substitutions. Intuitively, so that's also something we talk about. When you are expecting smartphone, for example, on the left-hand side, when you are expecting smartphone, we can substitute it by instances of any of its descendant classes. For example, iPhone of type iPhone 11 Pro, it's a descendant class. And also Galaxy S10 Plus is also a descendant class. Huawei P30 Pro is also a descendant class. So we can substitute either of them for the my phone of type smartphone. That's something we kept emphasizing in the previous lecture. And intuitively, it's because the descendants accumulate code from its ancestor, and also so that's why you can expect more, strictly more on the descending classes. So this is just a quick brush up from the previous lecture. So now, what we would like to talk about is how can we actually use contracts in both the parent class and child class to really ensure we can guarantee such substitutability. So that's something we'd like to talk about right now. So such substitutability can be reflected on contracts where a substitutable instance will. So let me give you the guiding principles first before we talk about some example to give you more rules, more analysis. So whenever you talk about precondition versus postcondition for a child class. So now let's say this. For the child class, so where a substitutable instance, so whenever we talk about substitutable instance, we are really talking about a descendant class instance. So a child class instance should not require more, which means they should always require less from clients for using the services. So what does that mean? For example, if a input value is actually allowed by the parents by the parents class precondition, then in that case it should be also allowed by the child class instance. In that case, the child class cannot require more, right? The second one, the child class instance should not ensure less. So whatever benefits that's actually ensured by the parent class postcondition, it should at least be also allowed, also ensured by the child class instance postcondition. So I'm just talking about a little bit informally, verbally, but I'm going to show you exactly what it meant. Okay. So before you actually move on to the next slide, try to not really to memorize, but try to imagine how you can gain intuition just yourself about these two guiding principles. So whenever you got any descending class instance that's actually for substitution, you want to make sure both guiding principle. For the precondition, you should always not require more, or you should always require less. And for its postcondition, you should always not ensure less, meaning that you should ensure at least you should ensure more. Okay, for the postcondition. So we're gonna use this particular example, a hierarchy. You can think about it's like a simplified version of the inheritance hierarchy that you learned in the review lecture. Let me just talk about exactly the scenarios that we need to consider. Let's say this. We got some phone user over here, and statically my phone is simply of type smartphone. And smartphone is basically referring to the parent class over here. And then let's say we talk about one particular query, get reminders. Let's say we want to get reminders for maybe stuff that should be done today. And then that will simply be a list of events. Events, you can think about it's simply defined somewhere else. Simply the events, for example, maybe I need to finish my assignment 1. Maybe I should really say hello, say happy birthday wishes to one of my friends, and etc. Right? So in this case, for the get reminders, we should have some precondition and postcondition for this particular parent class. Let's just say for now, let's say for the precondition, it's going to be alpha, okay? And for the postcondition, it's going to be beta. Okay, let's say. And let's say we also got some one of the descending classes. We just consider iPhone 11 Pro. And then that one there is simply just going to maybe redefine the get reminders, and the signature should be the same, right? It's still returning a list of events, and itself also got precondition and postcondition. I will explain later why we need an else and then over here. For now, just take it for granted. Syntactically, you cannot simply just say require and also ensure. You have to say require else and also ensure then. It has to do with exactly how the subcontracting is actually checked at the runtime, which will be the topic for the for later videos. And let's say for the precondition over here, so let's say this will be gamma and this will be delta. Okay, let me just use a consistent color over here. So that'll be delta over here. So the green ones for precondition, you can see alpha versus gamma. And also the pink ones are actually for the postcondition. You got beta versus delta, right? So now we got 4 different predicates that we have to worry about. Okay, let me set the context right, and then we'll discuss maybe 2 different examples to really give you the proper intuition and also to explain the static analysis rules that you have to consider. Let's say we have the following declaration. We say my phone is of static type smartphone over here. Okay, and then first of all, we're going to substitute my phone by some dynamic type. So since we don't have the curly brackets over here, so we are simply substituting it by smartphone, right? So now that would be actually valid because smartphone is simply the descending class of itself. Let's visualize it. So my phone at the runtime, after the first instantiation, so let's say this is our first instantiation, the first one. So after this, my phone is actually going to point to some dynamic some objects of dynamic type, simply smartphone, right? As we explained. So that will be smartphone. Okay, smartphone over here, just for short, SP, smartphone. And then, so let's say this. When we are invoking this get reminders feature or routine over here, so now dynamically it's really pointing to a smartphone over here. So that means the precondition and postcondition we're gonna check conceptually, right? So this is only informal thinking. So you'll be require and also ensure over here. So that means at this right before this, we're going to check for alpha to make sure alpha is actually satisfied, and then right after, upon the completion of get reminders, we're going to make sure the beta is actually satisfied. Okay, so all I want you to get clarified over in this page will be just about dynamic binding is going to make sure the pre and post condition that we define in the corresponding class is going to be checked. But exactly how it is going to be checked, it will be the topic for later. But for now, just conceptually, you can think of it that way. Okay, and then so let's now talk about the second object creation over here. So now we are substituting the my phone by this particular dynamic type, which will be valid because iPhone 11 Pro is also a descending class of smartphone. So this will be okay. It's a valid substitution. So what we're going to do is my phone, rather than pointing to this smartphone over here, is now going to point to a iPhone 11 Pro objects. So it's going to be iPhone 11 Pro objects over here. And then, so now when we try to call the same routine over here, get reminders, because the dynamic type for my phone has been substituted, has been modified. So now it's going to call different versions of the pre and post condition. So specifically, so now right before this, because now the dynamic type is actually iPhone 11 Pro, so it's going to call gamma, right? It's going to call gamma. And then, what about upon the completion of the get reminder? So now upon the completion of that, dynamic type is still iPhone 11 Pro. So we're going to call delta over here. All right, so now let me recap. Basically, we are making this identical call, my phone that get reminders and also my phone that get reminders. We are doing this, so the dynamic binding that we spoke about before in the review lecture, exactly the version of implementation of get reminders is going to be called depends on the dynamic type. So now we are just extending that discussion over there. So now the exact version of the precondition that's going to be called alpha versus gamma is going to depend on the dynamic type for either here or here, and similarly for post condition, beta versus delta. Okay, so that's the picture I would like you to actually keep in mind. And then later on, we're going to see given some specific value for example, alpha versus gamma, should that make sense? Let me first of all write down the rules that you're going to follow, and then we'll see concrete example to gain more intuition about the rules. Let's talk about the precondition first. So now for the precondition, rule. So the precondition over here, so the child or descendants should require less on the inputs. Okay, we already talked about what it really means logically to require less on the input. Okay, so now more precisely, we want to make sure when you compare alpha versus gamma, what does it really mean? The child require less. So that means alpha over here should really imply gamma. So intuitively thinking this way, whatever input value that can satisfy alpha, the parent's precondition there, is guaranteed that value can also satisfy gamma, right? So whatever you can satisfy in the parent class, you shouldn't get any surprise in the child class, basically as the input. Okay, that's one side. The other side for the story would be the post condition. Okay, I'll put it here. So now, what about the post condition? And for the post condition, so the child should ensure more, okay, on the output. Okay, so now we talk about post condition, so beta versus delta. So we also talked about previously what it really means logically when we say ensure more. So that means delta over here, the child post condition should imply the parent's post condition beta. Okay, so now intuitively, how can you understand it? Let's think the following way. So you want to visualize what's happening over here. So when you talk about the beta over here, think about these are all the possible output values that's actually ensured by the parent class, right? The beta over here. So that's the beta for the parent class. And now we are saying the following. When we talk about, let me use a slightly different color here, let's say red. When we talk about the post condition for the child class over here, delta, so we're saying that we're going to make it slightly harder or strictly harder for the supplier to actually implement the same routine. So that the output value that will be considered as satisfactory is going to be a subset of the parent class. So this will be the delta. So you can think about when delta is actually used as a post condition, so that means the delta over here, it will be harder to actually satisfy. Harder, let me put it in quotes, to satisfy. Simply because it's simply just a strictly smaller set of acceptable output value that will be allowed for the child class. We will see some concrete example about delta versus beta for the post condition in a later example. Okay, so let me recap about the rules that you should really know before you see the example. So when we talk about precondition over here, you should really make sure alpha actually implies gamma, right? So alpha over here should really be stronger than gamma. Well, gamma is actually weaker than alpha over here. And then what about post condition? So when we talk about post condition, we want to make sure delta implies beta. So the delta, the post condition in the child class should really be stronger than the post condition in the parent class beta.